Alright, hello everyone. We're going to be doing some code review on valor-lang, which is what I've been working on recently. This is just a video. So this is our code we have so far. Again, we're going over a book. It's by, let me just open it again. So this is by Ball Thorsten. And basically we have one for interpreters and compilers, but today we're going to be doing our interpreter. I plan to convert this to a compiler eventually, but for now it's going to be an interpreted language. But the goals for the language are performance, readability, and simplicity, similar to Golang or Zig. So yeah, that's the idea. But for now, let's go ahead and work on this. I'm going to go over some stuff. So we have a next token. We have a couple functions here. I'm going to make a wiki for this code base just so I can look at it, and I'll add some stuff to that so it's easier to explain what's going on here. But firstly, we have a lexer struct, and then we have, so this is how we create it obviously. A lexer basically takes a string, converts it into tokens, and then takes a string, reads the inputs, reads each char one by one. It keeps track of has 2 pointers, right? It has read position and position. Both of these are pointers to the current char that you're looking at, and then a read position will be updated. The position will be updated based on the read position. So, for instance, if we have, if we're looking at a keyword, so like for, we would see f, and then if it's not one of these, so in our next token, we look through this. If it's not any of these, we go to our default case, and it says if it's a letter, then we're going to read the identifier. And read identifier does, it sets the position, so this just stores the position of the lexer in the variable called position, and then it checks, is this a letter? And if it is, it reads the next char. And then so l.input, the lexer's input is now from position to l position. So yeah, it's going to keep reading until it gets to the next it gets to a non-letter character. And for that, we have this Boolean function. Basically, if it's a lowercase or capital letter, then it's part of an identifier, or if it's an underscore. So underscores are allowed. They can be treated as identifiers. In other languages like Java or JavaScript, stuff like that, you can put underscores and numbers. I think you can do numbers. Wait, I know you can do numbers in Java classes, and well, yeah, of course you can do numbers and variables, right? So yeah, in those languages we would have something for that as well, but not for this language for now. We're trying to keep things simple. So again, we have 2 pointers here. If the read position goes over or equal to the length of the input, then we just set it equal to 0. The character itself equals 0, so it has no value, right? And otherwise, we set the character we're looking at, to the character at the index of read position. So right, so read position reads the next input. We don't want to, have one pointer, because if read position did go over or equal the length of the input, then we still want to know like what the previous position we had was. And again, like when it comes to this thing, when we're looking for looping over an identifier, having 2 pointers is useful, because we keep track of the position that we were initially at when we ran into the first identifier character, or just anything that's not one of these tokens. So yeah, that's how the lexer works. And so what we want to do now is, again, so yeah, this basically converts, so this is our, in our switch, we call this new token, and it's a bit weird, like, at least for the book, I don't know why we're not just using the constants here instead of using, like, we have strings that are associated with these constants, and to me that just seems kind of like meaningless, right? Because we have the constant, therefore if we ever need to get the string for that constant, we can just use a switch statement, right? But I guess it can be useful. Say you want to just get whatever symbol it is based on this token, you can do that. But I mean, but yeah, I guess the question comes from that is like, why would you even get the symbol? Like, what are you trying to do to get the symbol? Like, right? So in that case, trying to think, if we're doing a switch case here, why would we even care about the actual symbol? I don't know. It just seems like we're holding more memory than we need to, right? But for now, let's keep it, because it might be useful, right? I don't know. We don't know enough to really make changes like that yet. But yeah, let's go back to the book. We're gonna read this. Okay, so yeah, we updated this. Wait, did we? Okay, what did we do? Did we update it? Yeah, okay, they added new stuff to it. They added slashes, they added stuff like that. Okay. Yeah, so I guess we can do that. So equals, let's see. Let's make a couple cases actually. Nice thing about using NeoVim is you can do stuff like this, if it's gonna work. As soon as I say that. But no, if we want to do like a couple cursors, we can do this. Then we can move over. But I need to actually do something else here. Let's see. We need a comma. Let me make a couple spaces here, and that's what I need to do. So if I want to do, okay, a couple spaces. If I want to do a couple cases, right? I can do Alt-Shift-C. And I guess it's not going to count those other spaces in there. I'm still learning, but what I want to do is just, let's see, can we do this? There we go. Okay, and then I can just type, we can just do case, and then those aren't going to be the same, but we can do colon, right? And we can also do this. We can go down one, then toke equals new token dot whatever it's going to be, and then .ch. Really nice, right? And we can put a semicolon. I love this. So much productivity, all from Vim. And if we want to put some single quotes, we can do that. But yeah, now I can press, comma to just get rid of that, and then we can go ahead and do this. So we want to add plus, minus. No, we already have plus. We don't have minus though. So let's go do that. It'd be nice if we had them next to each other. So, but that's fine. Exclamation points. I don't know what we need that for. That's weird. Oh, for not equals, right? Divided by. Let's add some more cases. I hate how they're not like lined up. Okay, not to do that. Gotta go here, and then we can do it. Okay. Case, semicolon, single quotes, colon, and then we can do this, token. We can do token dot ch semicolon. Lovely. This is my first time actually using like the this is actually Helix. This isn't NeoVim or anything, but pretty similar in terms of key bindings. It's a lot easier in my opinion because you can do like I don't know if this is in NeoVim or not, but you can do like W automatically selects. Like I don't know if that was in, but it's in this one. You can actually type V to just go and select mode only. Pretty sure that was also in NeoVim, or just Vim. And then we have if you press X, that selects the whole line. And you press D, that deletes stuff. So it's a little different, but let's see what else we need to add. We need to add the arrows, the angle brackets. I mean, that's why I did that. We need to add the asterisks, right? Asterisks. So that's just one case. Token. Oops, token equals new. Token. Do we have asterisks in here yet? We don't. I'm gonna copy this down here. Okay. So, did we add that? No, okay. He's adding it here. Okay. Right. I think I went ahead too far, actually. No, I didn't. Okay. With this added, our test pass. I don't know if you noticed, but we simplified things a lot in read number. We only read in integers, but what about floats? What about numbers in hex notation, octal notation? We ignore them and just say that Monkey doesn't support this, of course. The reason for this is again the educational aim and limited scope of this book. It's time to pop the champagne and celebrate. We've successfully turned the small subset of the Monkey language we used in our test case into tokens. With this victory under our belt, it's easy to extend the lexer so it can tokenize a lot more of the Monkey source code. So yeah, I'm really just pretty much copying Monkey for now, and then whenever we have everything set, we can go ahead and customize it to our liking, right, for our language. Extending our token set in lexer. So our token set was just a switch case. It's actually a set of constants, but you saw it in a switch case. And then in our lexers, we went over that. In order to eliminate the need to jump between packages when later writing our parser, we need to extend our lexer so it can recognize more of the Monkey language and output more tokens. So in this section, we will add support for equals, exclamation point equals, minus, divide, multiply, greater than or equal to, less than or equal to, or whatever. And keywords true, false, if, else, and return. Interesting, okay. The new tokens we will add, build, and output can be classified. Now, the new tokens we will need to add, build, and output can be classified as one of these three. 1 character tokens, for example, minus, 2 character tokens, for example, equals, and keyword tokens, for example, return. We already know how to handle 1 character and keyword tokens, so we can add support for these first before extending the lexer for 2 character tokens. Adding support for minus, divides, asterisks, less than, greater than, and trivial. First thing we need to do, of course, is modify the input of our test case in lexers/lesser-test.go to include these characters, just like we did before. In the code accompanying the chapter, you can find the extended tests table, which I won't show in the remainder of this chapter, in order to save space and to keep you from getting bored. Okay. Okay, let's see. So yeah, we talked about, we're using a different test case here. So if I go do, wait, why do we have an error? Oh yeah, because we didn't specify any of these tokens, but if we open Lexer, oops, we'll open Lexer test, you can see that we have, this is like the language, right? This is the source code that we're now interpreting. And this is just the Go has a built-in unit testing framework, which is pretty sick. So we can just use this testing.t. I guess t is a class for testing. It's a struct array. So this is like an anonymous struct. I have no idea how that works in Go, honestly. I'm pretty new to Go. I've started like literally last week, but or this week or whatever. But yeah. Okay, so we have a struct array, bit of type token type, and a string. I think it makes sense. Yeah. So it's like an anonymous struct. We specify what the type is by literally writing the struct. And then we can just fill in the array. And arrays in Go use curly braces, so that's nice. But of course they do. Okay. Is this an array? I think it's a slice. Based on the fact that it doesn't have anything in here, I assume it's a slice, but I don't know. I don't know much about this language. Okay, well, let's see. So yeah, we're taking input, we're going through each token. So you can see how this works, right? We're printing token, data type, and then this fatal if. So there's some stuff going on here. T.fatal, fatal f, not fatal if. I'm guessing it just prints something out if it's incorrect. Yeah. Okay. Well, everything, this test case, I mean, this test is fine. Let's see, flexor. I want to go to, right, I want to go here, don't I? No, I want to go to, I want to go to the main. Wait, do I? No, I don't. That's not main, that's main.valor. I want to go to token, because this is where it's going to have tokens, the constants, yeah. Here we go. So we have a legal, we have EOF for our end of file, we have endbend, we have int, a bunch of single identifiers, right? So, okay. And these would all be considered tokens, actually. So we have single character tokens, and now we want to add, we had function and let for keywords, but now we want to add more, right? So we have, let's see, what do we want to add? So, oh, we're not doing that yet. We're doing single character tokens first. So that's going to be under operators, right? Ugh. Oh gosh. That was not a curly brace. Okay. X. Why is X going to the next thing? I hate that. If I go D, there we go. Oh, it's supposed to be D if it's just one space. Okay. So we're gonna have to go in a little bit because I have to go eat my grandparents. So let's go ahead and add to operators here. We have minus. We have bang. So exclamation point. We have asterisk, like we did before. Just, there we go. And we have slash. Oops, slash. Sorry, my keyboard's so loud. Oh my gosh. And then we have some other operators. We have equals, less than, and greater than. Right? So this is what we added. We added some stuff here. With the new constants added, tests still fail because we don't return the tokens with expected types. Right. So I already updated my test. That's what we first did. Make sure we save this file. And then we go open, Lexer. Yeah, so we already added all the, you can see we're doing some stuff here. So we have what exactly? Where's our new tokens? Do we have any? I can't see any. Did I change? Did I update the output? Did I update this? I didn't. Okay, we have to do that first. I'm just gonna copy this because it's the easiest way to do things. I don't know why there's no, okay, there is. I didn't see that. So yeah, let's go ahead and do little V, visual mode, and then insert mode. Doesn't work. I never figured out how to actually get that to work. Can I do shift? No. I mean, it kind of works, but it's all jacked up. I'm just gonna use my mouse. It's not the end of the world. Why does it do that? If someone knows why that happens, please let me know. This thing is weird. We could just type it real quick. Yeah, let's do that. We learn as we go. So yeah, that's right. Results, add 5, 10. And then we want to do exclamation point minus divide asterisk 5. And then 5 less than 10 greater than 5. There we go. So our test looks good. We added the const already. Let's go ahead and do our test. So just quit. Oh wait, lecture.go. What did we not? Oh yeah, let's save that. Let's quit. And we can do the test. So go test / lecture. Yeah, so about what we expect, right? Syntax error, unexpected comma. That's not what we expect. But I mean, it is what we expect, right? Okay, so if we go to open, what it's complaining about is this. If we go here, 24J, if we go here, you can see I have token dot, but I haven't actually specified what it is. So let's do that now. This is less than. This is greater than. This is slash. And this is bang. Love that as autocomplete. Nice autocomplete. And then this is subtract. It would be dash. Is it dash or subtract? Let's see. Minus. It's neither. So we do have this constant set. And what's wrong here? Forgot our semicolon. No, it doesn't matter. What's wrong? Did I spell it wrong? Yeah, I did. Asterisk. It's asterisk with an S. There we go. Right and quit. It's clear because I don't know why, but it goes down. Like I don't know how to fix that with my sys too, or msys too. But let's go ahead and run this test code. Lecture that go. Go test, no test files, really? Oh, I did the wrong thing. Not supposed to specified lecture.go, obviously. Let's see. Yes. Okay, this is exactly what we wanted because we expected that, but we got illegal. And so yeah. Alright, well, I'm gonna take a break, I'll come back and we'll continue doing our stuff. Alright guys, we're back. Let's go back to I was just on Discord for a little bit. Let's go back to our code here. Our tests work now, and so, oops, that's not this. Let's go to let's update our code. So, go off Discord. So let's go ahead, I'm just going to close out everything here, don't need it. Let's go ahead and go to our book here, and so let's go ahead and keep reading. Tokens out of the case. This page find the structure of the token. Watchers make our test pass. So maybe we didn't. We need to fix our tests. It looks like. Yeah, we do. Okay. Because our tests are not passing right now. Yeah. So let's make sure we have everything. I don't know if we specified let. Maybe we need to do that. So let's see. Let's see if we got everything. Okay, this looks fine. Let's make sure though. Okay, assign. Let's see how they do it. Minus equals comma. Everything looks good. Okay. Let's make sure. Let's go up here and see. We should have done everything in this because we have these constants here, so that confirms we did this right. I think we need to go to our test code, make sure it's updated. Right, okay, I see what we did wrong. We did not update we did not update this. Okay, we went ahead a little bit too far. So let's go back up. Yeah, we were around here. Okay, so let's read here. So the isLetter helper function checks whether the given argument is a letter. That sounds easy enough, but what's noteworthy about isLetter is that changing this function has a larger impact on the language our interpreter will be able to parse than one would expect from such a small function. As you can see in our case, it contains the check ch equals underscore, which means that we'll treat underscore as a letter and allow it in identifiers and keywords. That means we can use variable names like foo underscore bar. Our programming languages even allow bangs and exclamation point in identifiers. If you want to allow that too, other programming languages even allow. Okay, this is the place to sneak it in. Read identifier does exactly what its name suggests. It reads in an identifier and advances our lecture's position until it encounters a non-letter character. In the default branch of the switch statement, we use read identifier to set the literal field of our current token, but what about its type? Now that we have read identifiers like let, fn, or foobar, we need to be able to tell user-defined identifiers apart from language keywords. We need to use a function that returns the correct token type for the token literal we want. What better place than the token package to add such a function? So yeah, let's go to token. We're gonna go here. What is going on? Okay. I guess this isn't an error. It's just acting like an error on the side. Okay. So yeah, we need to make a, what is this? A var keywords. Did we not do that? I thought we did keywords. Huh. Okay. Well, I guess we make a new one called var keywords equals, oh, come on. What's going on here? There we go. Var keywords map string token type fn equals function. Okay, I see. This is a constant. We do want our constant straightened out. Let's set constant. Okay. We also want a func. If toke, okay, never used this before. There we go. It's a server function. So we're taking in an indent, or no, sorry, an identifier, just shorthand for identifier. I kind of don't like how that's shorthanded because it almost seems like an indentation. I'm going to rename this to ID just because it's shorter and it's more clear, right? Oh my gosh. Sometimes I use the wrong motions. ID to me just is more clear and concise, right? So let's go do that. Look up indent, checks the keywords table to see whether the given identifier is in fact a keyword. If it is, it returns the keyword's token type constant. If it isn't, we just get back token.indent, which is the token type for all user-defined identifiers. Oh, so wait a second. Where is indent? It's here. Okay. So it's just a generic. Oh, it's for like names and stuff. Okay. Yeah, if it's not a keyword, we just return indent. Otherwise, we return one of these, right? Either function or let based on the string. That makes sense. Okay. I think I understand. Okay, so this is like destruction syntax. What is it called? Destructure? Something like that. I know there's a name for it in Rust. Tuple deconstruction, I think. I'm actually curious. Deconstructing a tuple in Rust. There's a name for this. I know I spelled that wrong. Breaking down the tuple's items into components. There's a few ways to destructure. That's what it's called. Then I got 4.0 out yet. Okay. Yeah. So destructure. I'm just gonna call it the same thing because it is really the same thing. We the okay. What is that though? I honestly don't know what the syntax is to be honest. I thought I did, but this okay makes no sense actually. I guess if it is okay, return. What is the okay? Whatever. Ooh, there I get doxed. Doxed again. Okay. So what can I do? We have all this stuff. Let's go back to the book. And now we have to update our next token. Look up in it, yeah. With this in hand, we can now complete the lexing of identifiers and keywords. So let's open back our lexer. Let's open this. Let's go back here to the next token function where we handle all the tokens. We handle our current. This is really just handling a current character, right? That's all it's doing. So okay, now I'm gonna token, toke. Yeah, we're just using an unnamed return here, a naked return as it's called. So we don't have to specify that toke. We did it in the return argument list. And then with the switch, we do that. Yeah, so we already did this we already did this part. Actually, wait, let me check. I don't think we did actually. Yeah, we have to change that. Okay. So default is letter. We did that. Literal, read identifier, toke type equals token dot look up ID toke dot literal. There we go. And we need to import this for some reason. Oh, did we not? I think we updated or wrote to the. Let's make sure we write to it. Yeah, so it is being used. Any errors still? Why? Lookup ID? Token. Oh, wait. What is token? Token is this. Wait, what even is token? What the heck is token? Is this the first time we're using token in here? No. Let's try getting rid of that. Oh, I have a capital L. What is wrong with me? Oh gosh. I hate when this happens. So toke.type. I mean, I think, right? Or I think I still got it wrong. Oh, why, dude? This is so annoying. We're importing token. What is this error up here? I wish I could see it. What is this complaining about? Oh, this is not capital. Dude, the thing with freaking Rust, man. I mean, not Rust, Go. You have to capitalize in order to make it public to other packages. That is weird. That's gonna take some time to get used to, honestly. Now it should work. Yeah. No? Dude, come on. What is this? Oh, we're using a capital U. Now it should work. There we go, finally. The earlier exit here, our return toke statement is necessary because when calling a read identifier. We call read char repeatedly and advance our read position in position fields past the last character of the current identifier. So we don't need to call the next token after the switch statement again. Running our test now, we can see that let is identified correctly, but the tests still fail. This problem, okay, the problem is the next token we want, a ident token with 5 in its literal field instead we get an illegal token. Why is that? because our white space character between let and 5. But in monkey, white space is not significant, so we need to skip over it entirely. Yeah. So we need to put some sort of function here. L dot skip white space. And then for that, we just make another function. I bet I can figure this out on my own. Skip white space. We just return. No, wait. So what we do is we want to call read identifier if it's a white space. So if ch equal this. Let me get rid of the parentheses. So if the char equals a space, we will just call read identifier. That should work, right? What's wrong here? Type lexer is no. Okay, wait. Oh, I didn't put in L lexer. It's not a method. What's wrong here? Read identifier returns a string. Oh, wait. Wait, okay, what is calling read identifier? The next token is next token read char. What is calling next token though? Read char. I do want to call a read identifier, right? I want to read the next identifier. Or do I want to call read char? Maybe I want to call read char. I don't know. What does read char even do? Looks like we're gonna use read identifier, I think, because that's going to yeah, that's gonna move our stuff up. Okay. So we want to call read identifier. What is throwing this error though? L.read identifier is what we need to do. See how they do it. Nice. So we got it pretty much. 4. Wait, hold on. What's read char? What the heck? Why would we call read char not read identifier though? Wait. It's not an identifier. Oh my gosh. Read char, the space is not an identifier, right? It's just a space. So we don't want to call read identifier because that will do multiple chars. See, look at this. It's a for loop, right? If it's that. So when it's not an identifier, we just use the other one. So read char. Char is the most basic. This is the most basic incrementation of the lexer. Let's see, they do some ors here. They do 4, right? That's what you're supposed to do. So this is kind of like read identifier, except it's skip white space. Okay. So this looks good. This little helper, oops. This little helper function is found in a lot of parsers. Sometimes it's called eat white space, and sometimes consume white space, and sometimes something entirely different. Which characters these functions actually skip depends on the language being lexed. Some language implementations do create tokens for new line characters, for example, and throw parsing errors if they are not in the correct place in the stream of tokens. We skip over new line characters to make the parsing step later on a little easier. With skip white space in place, the lexer trips over the 5 and the let 5 equal 5, yeah, part of our test input. And that's right, it doesn't know yet how to turn numbers into tokens. It's time to add this. As we did previously for identifiers, we now need to add more functionality to the default branch of our switch statement. So yeah, a bunch more functionality going on. See if I can come up with this. Probably gonna bust it up, but let's see. So I want to check if it's a digit. We need to do an if else. So I guess I'll just do if. Wait, how do we do if else in here? It's else if, not if else. It's always been else if. I've been tripping. Yeah, so is digit. This is going to be another thing we do. If it is a digit, then we do the token literal equals just l.ch.parse. I don't know if there's a parse thing. And then the type is just token. Is what? Number, value. What would it be? It would be how do we do numbers? Would it just be? I need to go back. Let's go to token. For numbers, it would be int, right? So we would do int. And I don't know about parse. We need to add the is digit, obviously. So let's do that. Let's add the is digit. Let's add it next to is letter. So ch bytes. Brings a bool. I love how there's no difference between bytes and chars in this language. It's really nice. I'm sure we have to be able to parse it somehow. Do we create a read number? No, I guess it's just a it's the method of a. Wait. Oh, we have to create read number. Yeah, so let's make read digit real quick. Yeah. So if it's a decimal number, then that is a number. So C. Okay, wait. Yep. Okay. We need to do read number func. So returns a string. Promise I'm not copying code. I'm going to think about this. So, well, I actually don't have no idea how we parse numbers in Go yet, so I can't really do that. What is wrong here? Oh, we forgot to put the other one. So if I'm just gonna do a little experimenting with helix. So I just select all this. I'll just hit comma. No, not comma. It's semicolon. We're good. So if I do a little www, I just hit semicolon to unselect that. Okay. For this, I don't know. What do? We do what? For read number, we call isDigit read char. Oh. We just treat it. We don't have to parse anything. Oh, it's just like a letter. Come on. We just did it, right? isDigit. So same thing. We just call for isDigit of our ch. Maybe rechar. We keep reading the chars, and rechar should call next token. No. It's not what happens. Next token is called by our user, our consumer of the token class. Sorry, the token file. The lexer. Sorry, my brain is not working. So yeah, we want to return a string. What are we returning exactly? Ooh, okay, we're doing this exactly like we did a read identifier. So we're updating the lecture's position as well, which makes sense, right? We want to consume the entire number as the identifier, or as the int, right? The entire int as the int. So what we can do, so yeah, we just treat this the same way we treated read identifier. And so, okay, so we update the position based on, we just store it in a variable. I'm not sure why we do this, but let's see. Because it's going to update once we go through this for loop, it's going to update the position. We want to make sure we keep the position so that we can return the entire number. That's right. Oh my gosh. Okay. We want to return the entire number as a string. Okay. So the way we can do that is we can do input, and this is like a substring. The original position, which is what we stored, and then that position where it's actually at. Just like we did read identifier, and then we're good. We return that. We don't call parse. We call read number. I gotta get in the habit of doing EC immediately, right? Read number. And this should not be called with CH, it should be called just like that. And we should pass in, wait, read number? Did we forget something? Oh shoot, I didn't do this right. I didn't do it right for isDigit either, did I? I didn't do it for skip white space, I didn't do it right, let me see. Yeah, I'm gonna conflate this a lot, so with this, we don't pass it in as an argument, it's just a method, we gotta do it out here. Very weird, but yeah, makes sense though. Same thing here, we don't do it here. There we go. So, okay. Okay. Skip white space. We have our tokens. Okay, so you have an error. Let's see what it is. Undefined. Skip white space. Yeah, I think that's how you spell it. What is it actually? Skip white space. It's up here, right? Yeah. I'm guessing the S is the problem. Yep. So let's see. Yeah, so reading different, you're looking this up. Was there a difference? Was there even a difference in using it up front? I'm curious, let's see. Was there a difference? So let's use V. Let's delete this. Place it here. Okay, what's the issue? Oops. Yeah, the issue's up there because it's like, yeah, okay. There is a difference. There's a massive difference. So we have it. We have everything set up now. We read number if it's a digit. Anything else we had to do? Return token. We didn't do that. So let's do that. That looks good. Yeah. So let's go. As you can see, the added code closely mirrors the part concerned with reading identifiers and keywords. The read number method is exactly the same as read identifier except for its usage of isDigit instead of isLetter. We could probably generalize this by passing in the character identifiers functions as arguments, in the character identifying functions as arguments, but won't for simplicity's sake and ease of understanding. Yeah, so this is the higher order functions being demonstrated here. So we could probably generalize this by passing in the character identifying functions as arguments. Because we have two functions that are similar enough, we could generalize the function into a higher order function and just create, just add a function as an argument. Therefore, we can piece together what we want based on the arguments instead of just hard coding each individual function. So that's the idea behind a higher order functions. The isDigit function is as simple as isLetter. It just returns whether the passed in byte is a Latin digit between 0 and 9. With this added, our tests pass. Okay, let's see if that's true. So go test Lex. Lexer. Oh man, come on. So they don't pass. What is it? Why is it printing out stuff then? Oops. So yeah, we added this stuff. What do you mean, dude? Okay, let's make sure you have all our stuff here. Did we actually update this fully? No, we didn't. Of course it's not going to work now. We have to change this as well. How do they even pass the tests? If they add this, they have to change this, the actual test cases, right? So how are they passing? I think that's the issue here. So yeah, let's actually add those tokens and see if the test pass. So not EOF yet. Can add it there. So after the semicolon, there is what? There's some white space. Ooh, what is this? Oh my gosh. There is a ln, but we skipped that. There is a bang. There's a negative sign. You can just look at it over here. I hate how it's not telling us what our tokens need to be. I guess we just gotta know to update that. Yeah, the Lexer should only turn this input into tokens. For that reason, the test cases I write for Lexers cover all tokens and also try to provoke off by one errors, edge cases at the end of file, new line handling, multi-digit number, parsing, and so on. That's why the code looks like gibberish. Okay. So yeah, we gotta add this stuff now. So we have bang. It's really annoying, right? It's really tedious work here. We gotta get it done. I'm gonna end the video when we get these tests passed, okay? Oh, this is so annoying, but I have to do it because I don't think I can just cheat by every guy. Oh. Should probably save myself some time by just doing this. So what we can do is we can do a little trick here. Shift C, Shift C. Oh, it's not gonna work. It doesn't actually do anything. Oh god. I need to do a little bit of these before I can do that. Shift Alt C. Wait, no. Alt Shift C. There we go. See this? Why did they get rid of it? I'm so confused. Shift C, Shift C. There we go. Token, whatever it is, comma, and stuff, and then freaking commas. There we go. See how nice that is? I could just press comma to get out of it. And so we got 5, and then we got less than, so it's gonna be LT. C int. We got one more. Let's see if we'll have our mercy. Yes! We did it! Feels so good. Okay, I'm going to bed now. Yeah. We did it though, nice. How many seconds? Nope, nothing. New one, okay. I assume we're pretty much done, right? Okay. I could almost do the other stuff as an exercise. All it is adding keywords, and that's really straightforward. We just add it to this, we add it to this, and we're done. We just update the other stuff. Okay. Well, I'm gonna keep making videos. This is the second episode, but we are done. This is a long episode, but yeah. Thank you so much for watching. Make sure to like and subscribe, and yeah. Hopefully this turns into something big.